we have a special keynote address, an innovative use of daylighting in buildings to enhance workspace productivity. We all know the problems that India deals with power, and we'd like to make sure that our next speaker addresses these issues and more. Let us put our hands together as I welcome on stage Mr. James Edwards. He has been responsible for mixed use of developments in Mumbai and New Delhi, comprising of high-end residential, office and hotel towers with low-level retail. Let's put our hands together as I welcome him on stage. Ladies and gentlemen, Mr. James Edwards.
Ladies and gentlemen, thank you very much for the opportunity to talk with you today. As the delegates at the Paris Convention only get 3 minutes for their speeches, you have me for half an hour, so I hope you're sitting comfortably. If we can just start up the PowerPoint. Right. Actually, I don't have the pointer. So I will just get the pointer. My name is James Edwards from Foster+Partners. For those of you who don't know Foster+Partners, we're a global architectural practice based in London. We have 20 offices across the world and numerous active sites in... I'll start again in a second. Right, so we have 20 offices across the world and are working globally in a number of cities at the moment, including Gurgaon. We're working with Irio on a Grand Hyatt residential development just down the road. Now, we were established in the late 1960s and have a strong reputation for innovation and sustainable design, being at the core of our design ethos. We have and continue to undertake a number of building types and infrastructure projects across the globe. In the center here, you see the new Apple headquarters in Cupertino in California, and at the bottom, the Swiss Re Tower, which I'll come back to later. But we do everything from these large projects down to small cancer hospice in Manchester for Maggie's, and down to furniture, light fittings, and door handles. The scale and diversity of the global reach of the projects was unimaginable 40 years ago when we started. There we go. But what excited the team in the early days still excites us today, except that now we're a much larger office, multidisciplinary office of architects, engineers, project managers, researchers, and model makers. Now, we've been asked here today to discuss the subject of daylighting in the workplace and how that relates to productivity. In 1966, when Foster+Partners was created, daylight in the workplace was one of our fascinations, but its benefits were largely completely unrecognized. These are some early sketches by Norman of the Willis Faber building in Ipswich, where, as you can see, daylight was one of our prime, if not the prime, consideration. Willis Faber was groundbreaking in a number of ways, not least in how it utilized daylight to enhance the internal environment. So daylight fills the central atrium, and in that atrium we have the escalators that draw the users through the different office floor plates and ultimately up to the roof deck with the recreational facilities. It was the first office building to democratize the workplace. Up until then, different users could only use different areas. But it gave access to all users to all the facilities within the building. And the centrally lit atrium created the focal point for the building and gave it a sense of community. And I think Willis Faber themselves would admit that it completely affected their personality as a company. The exterior of the building hugged the medieval street pattern, so all that residual space that was just being discussed about was taken into the center of the building and utilized for the users in the central atrium. Now, in the context of the late 70s, this was a revelation. No one had ever approached an office building in this way. The workspaces were not like this. So it set the standard for all that followed, with daylight becoming the symbolic device to this new approach to the workplace. If we jump to the late 1970s and the Sainsbury Centre for the Visual Arts, an art gallery, a workplace for the staff, but also a study space for students and academics. And again, this is Norman's sketch from the 70s, and you can see daylight was high up there on the agenda. The centre broke the mold for the art gallery type by creating a single daylit volume from which the users could experience the art in one large space rather than the sequence of conventional gallery spaces. To achieve this, I'll just go back one slide to explain this. To achieve this, we got rid of the conventional building service core. And we put all the facilities of the building, all the air conditioning, the pipework and the plumbing and the lighting in that double band around the outside of the building. So we ended up with one large space. The arrangement of the solid, opaque and transparent panels of the cladding, together with these blinds that you see, which we could automatically adjust depending on the daylight, provided a completely tunable level of daylighting for the light-sensitive artwork. The fully glazed end walls allowed users views out into the landscape from both the gallery and the cafe ends, and it elevated the building to give long-distance views. So again, you can see the common themes of daylight, space, and views being a primary driver. In 1986, we completed what is arguably our most famous building, the Hong Kong and Shanghai Bank in Hong Kong. Here we were dealing with a very challenging climate. The client brief and the chosen site implied a very deep plan building with a very dense working environment. At the lower levels of the building, we introduced an atrium, and obviously being at the lower levels, it was extremely dark at those levels. To enhance the natural light levels within the atrium, we introduced a mirror device on the exterior, which you can see in the diagrams in the photographs on the left-hand side, which bounce light into that atrium. Therefore, you can see the density of the floor plates on the exterior here, and the sketch there indicates the importance of daylight and views from each and every workspace. So at the lower levels there, the workspaces had views out into the city, and on the inside, views through and across the atrium space. The entire building was elevated above ground, but the daylight that was bounced down through that atrium space and comes through this curved glass ceiling here transformed the underside of the building from being a leftover space into a space that could be used by the local community. And indeed, it is a very popular gathering space. These simple principles, with access to daylighting of the actual workspace, utilizing daylight as a functional device to aid circulation, providing focal and reference points to relieve the monotony of the repetitive floor plate, continued to develop and resulted in numerous buildings such as the Commerzbank in Frankfurt and the Swiss Re Tower that we have here in London. Now, it's actually, for those of you who don't know it, it's actually a circular building in plan. The proportions of the screen have slightly skewed it. The bullet-shaped Swiss Re has a number of triangulated voids that you can see on this plan, the grey triangulated spaces, that stack and spiral up the building to create the darker bands of glazing that you see on the photograph there. Now, these voids brought daylight deep into the plan, it brought views deep into the plan, it gave every workspace a sense of daylight, direct sunlight, all within a controlled environment, and the triangulated voids, as they spiraled up the building, dragged or drew the air through the building. So all the circulation areas are actually naturally ventilated. Now, this approach led to a 40% reduction in CO2 emissions compared with a typical tower of the same size. By questioning the prescriptive approach that building services must always sit at the top of the building, and in fact relocating those several floors lower down, we were able to place the prime social space of the building at the very, very top. Let's go on one. There we are. So this is the very top level bar, but actually there's a restaurant just below this as well for the building users. You can reference this approach back to the Willis-Faber rooftop, if you like, the recreational facilities on its rooftop, and also the Commerzbank Sky Gardens, and even the Reichstag in Berlin. Now, the glazed dome of the Reichstag introduces top daylight deep into the center plan of what was left as a shell after the World War. and the parliamentary chamber sits directly beneath this dome. Daylight levels were enhanced by a series of automated mirrors that you can see here attached to the central conical structure that sits above the dome, above the parliamentary chamber, which is through this glass floor. In the background of this shot, you can see the white shading device that tracks around this cone and provides protection from solar glare. The public will therefore, we introduced this ramp around the dome, which symbolically, at the point in time, was a very important symbolic device to elevate the public above the politicians. For the German people, it represented the redevelopment, so the demolition of the Berlin Wall and the reunification of Germany. For us, the Reichstag represented the coming together of several strands of thought, the use of daylight, views, connectivity, integration, accessibility, natural ventilation, biofuels, renewable energy, all contributing to a green energy story that achieved a 94% reduction in CO2 emissions. Since the Reichstag, our approach continues to evolve. This is one of our most recent buildings in Buenos Aires, in Argentina. It originally started life as a banking headquarters, but now has become the city hall for the mayor. It was actually acquisitioned by the city mayor. He liked it so much. And 1,500 employees. The workspaces are arranged on terraced office floor plates within the larger volume, giving improved communication between departments, and similar to Willis Faber, contributed to a sense of community. The canopy roof you can see in this image here, the undulating roof, tracks the circulation routes below with skylights, so the entire space is top lit in the majority, with added daylight from the glazed perimeter. The full-height solar shading on the exterior gives views out, contains the solar gains, but gives views out into the surroundings and the greenery of the local park. You can see the importance of daylight in the succession of our projects in each of the decades, 75, 85, and 2015 today, where we use daylight as a device for circulation, for workspace, and for general enhancement of the environment. A final note on daylighting. This is our office in London, entirely daylit. We have some lighting in the ceiling but for the nighttime, but during the day it's entirely daylit from a 70-meter long double-height wall, north-facing wall with fantastic views. So it gives everybody a sense of the exterior, a sense of the weather, a sense of the climate, a sense of what's happening in the city. So my talk so far has been focused on aspects of daylighting in the workplace, and it certainly has its role to play in sustainable smart design. But it must take its place along numerous other considerations. At Foster+Partners, we're in the enviable position of working globally, which gives us an experience of a wide range of sustainably related issues, varied climates, and a global understanding of current and future directions. Our approach is holistic. In more recent years, it's become fashionable to term holistic as smart. But what does smart really mean? This is the environmental pyramid, which illustrates the very basics in a design approach. How to mass and how to form and how to orientate your building will do far more for you than any of the other additions you can make. In the middle band there, with increasing cost, but with diminishing gains, you have things like intelligent management systems. At the very top, you have things like solar paneling. But they tend to be very expensive, and they tend to give you the least benefits. The other way to think of this final category is as some kind of sustainable magic powder. But throughout our experience, a sprinkling of this magic powder on a completed project will not give you a sustainably responsible design. The green agenda of any project has to be at the core of the design and considered along with all other aspects to maximize the gain in the lower part of that pyramid. A great deal of research has been done over the years to improve the understanding of the built environment and what makes a space comfortable and a pleasure for all of us to be in. The diagram indicates the primary considerations, and you can see there that daylight and views are part of them, but they're not everything to be considered. We do a great deal of research to analyze, investigate, and work with the latest thinking and academic reports that come out to inform our design to the built environment. One piece of research of late studied 220 workers, office workers, to assess their window preferences. Daylight and views were 2 of the 16 sub-factors they were offered for consideration. Alongside daylight, visual connection, prestige, and motivation were key drivers in users' preference for their window. So the user's perception of their workspace is complex. It doesn't rely on just daylight or just views or just temperature. It relies on a number of aspects. One of the most important pieces of research that we've found of late has for the first time quantified our subjective reaction to the immediate environment. The study identifies that when we were within a controlled environment, an air-conditioned sealed box, without variation in smell, noise, volume, temperature, we become subjectively indifferent to that environment. We feel okay, we feel fine, but we are comfortable, but we are not very comfortable. The brain scan on the left indicates an area of activity in the brain in such an environment. It's a fraction of our brain that we're using there. Compare that with the brain activity experienced in an environment where there is some degree of environmental variation. We become far more stimulated, blood rushes around the brain, using parts that would otherwise be left dormant. The environmental variation can be in any one of the peripheral sensory perceptions. However, for the first time, there is a scientific assessment and understanding to challenge the preconception that fully conditioned, controlled environments are the best for us, the most comfortable, and the most pleasurable, and the most productive. This graph illustrates a study by Carnegie Mellon University of replacing natural ventilation systems with mixed-mode approach. The study estimated that the average productivity improvement of 8.5% across all these studies translated into a financial gain of $3,900 per employee. Add that to a recent study from Harvard, and this literally came out a couple of weeks ago. It studied the user reactions across a range of activity types and found a marked improvement in stimulation and productivity in a green environment compared with a conventional sealed environment. Further improvements were found in the more sophisticated Green Plus environment, and therefore gives solid evidence in support of the move away from the conventional approach. Studies such as these have helped us convince 2 of our more recent corporate giant clients away from the conventional sealed air conditioning approach, which is something they would never previously have considered. So this to us is smart. It's not one thing, it's not one approach. It is the consideration of all aspects and understanding the humanistic response to our surroundings to benefit the client, the user, the wider society, and ultimately the environment. I'm conscious we're short of time, but I'm just going to quickly show you some seemingly random projects which, to make the point that we consider them all to be smart in their own special ways. So first of all, Mazda, we were asked to design a city from scratch in the desert in a zero carbon environment. We looked at the indigenous architecture, the forms, the massing, the materials. One fundamental observation we made was, with all that space available in the desert, why were the settlements so dense? It's a simple answer. Quite simply, density works with natural shading, natural ventilation, and creates spaces between buildings that offer relief from the searing heat. We learned the simple lessons that traditional public space employs trees for shading and water for cooling with tangible benefits. The building forms and their dense arrangement, self-shaded, and as this wind tower study showed, created a dynamic natural ventilation system. Deep window reveals and screens provide an effective means of tempering the air temperature. All these principles were then employed in Mazda City project and were actually all employed in our Irio development in Gurgaon. So here's a short video of Mazda. Now, much of this video is computer generated. A lot of it is also actually real. This is real. This is a transportation system that runs underneath the city level, so the streets remain free of traffic. That's a visualization there showing the rollout of that system across the city. Now, our post-occupancy studies verified our design intent that by utilizing and learning from the past, that we could moderate the temperatures without the need for expensive servicing strategies. So we just end this video here, and we'll go on to this, so this shows two streets in Abu Dhabi. One is a wide boulevard in the center of town. The other is a narrow boulevard in Mazda city. Now, this study, the post-occupancy study, showed an impressive improvement in the experienced temperature on those streets. It's also worth noting that Mazda was a heavy energy consumer. For example, these laboratory buildings, which form part of the university, by limiting the energy consumption through simple means and generating its own energy from this solar wind farm you can see in the image, Mazda actually produces more energy than it uses. So we're contributing a lot back into the system. Now, maybe one unexpected example of a sustainable design, the Millau Viaduct in France. Now, there was a portion of the route between Paris and Perpignan in southern France that experienced terrible traffic. 5-hour traffic jams were not uncommon. We were approached to solve this problem, but as well as solving it, we wanted to create something beautiful, of beauty, within beauty, and enhance the natural environment. The result was this bridge structure, which elevates the traffic high above the valley floor. Its intervention gives enormous relief to the local community, so we solved the problem. But it also, if we just consider the heavy vehicle traffic alone and not car traffic, the benefit in reducing CO2 emissions equates to planting 40,000 trees or effectively removing 150,000 cars from the French road system. Now, the next one, Dharavi, you may know about. A few years ago, we were asked to get involved in the Dharavi project. I'll speed through this because I'm conscious we're short of time. We sent our team into the local community to understand what could be done, what needed to be done, because we felt from the start that simply improving infrastructure wasn't really the answer to the question. So one observation we made, these buildings circled in yellow at the top here, fairly recently built within the Dharavi community, but they remain completely empty. So even though they improved the sanitation, the security, and the shelter, they did nothing for the community. They rejected it. So we went out in the community to find out why that was, and it became clear that any new intervention needed to deliver space to allow the residents to carry out their sustainable light industry of pottery and weaving. The new buildings did not provide that. We studied the existing structures as well as the social spaces, how the narrow streets benefited the functionality, and how that might be delivered along with the basics of sanitation and power. And I'll just fly through these slides here that show our proposal and how we might help the community. Now, there's countless things to talk about on Dharavi, but one important development which could be rolled out across any typical situation like that, something that we termed collaborative performance components. Now, these are basically household units. You can see here, I'll just explain that there are two plans here. One is a conventional Dharavi dwelling, and on the right-hand side is the dwelling after our intervention. So what we proposed was that all the typical household units could be combined into one to share the heat, share the grey water recycling, and how that could feed the multiple uses in the building. Now that alone would improve the living conditions within the dwellings and provide more space for the sustainable light industry. I'll just fly on to this is that element in production. Now, what does the moon have to do with anything? Well, we were approached. We've done a lot of work with in-house 3D printing technology and parametric modeling. And we were approached by the European Space Agency to investigate the possibility of constructing dwellings on the moon without the expense of carrying heavy building materials to the moon. So I'll play the video and talk over the top of it. So this video explains how we would take, I'll just let it run for a bit actually, and then I'll explain it. There should be sound with this, I think, but. So we should now see the capsule landing on the moon and deploying an inflatable habitation unit. There we go. And we then proposed the use of 3D printing technology with the natural material found on the surface of the moon, which is called regolith. It's essentially volcanic ash. And in exactly the same way as you might print a 3D model, we take that regolith and bind it together with a bone structure, based on a structure of human bones, to encapsulate that inflatable habitation unit. Now that gives an incredibly strong skin, which protects the interior from incredible temperatures, solar radiation, and meteors. Now we're continuing to develop this, and we're expecting to use this on the lunar mission within the next 10 years. Finally, drone port. Now, we collaborated recently with the University of Lausanne in Switzerland, a company called Redline, and the Norman Foster Foundation, to try and solve a critical problem, which was how to deliver medicine in Africa. Now, Africa's population is increasing at an alarming rate, but has very little infrastructure. An unprecedented amount of money would have to be spent to deal with the increasing population. Only 33% of the population of Africa have access to an all-season road, and an all-season road is basically a mud track, which is taken out of action in the monsoon. Now, the project was based in Rwanda. Rwanda has insurmountable medical problems to address. The project is based on using drones, two types of drones, to deliver this medical equipment. A 3-meter wingspan drone, which would be able to carry 20 blood transfusions, or a 6-meter span capable of carrying 10 times that amount, and some light industrial materials. So the result of the study was to locate 3 strategic centers, which by 2019 will service 44% of the population of Rwanda. The drone ports had to be more than simple receiving and distribution centers. They also needed to be flexible enough to become destination medical centers, community centers, markets, and libraries. So our response was to propose a kit of parts approach with the vaulted structures that you can see in the center at the base here. And there is a parallel with what we proposed for the lunar landings capsules. And then this is delivered by, the parts can be delivered by drones. They form the base for the drones, and actually a manufacturing base for the drones. Now the local community then used the local soil to create tiles that clad the building, the structures. This is a short video, the promotional video for that. I'll just let this run out. Maybe you could turn the volume up. In conclusion, I've got a red thing flashing in front of me that says get off stage. I return to the question of what is smart. I've just shown you some randomly different projects. That was purposeful to make the point that we consider them all smart. Smart to us is the analytical, investigative, questioning, research-based design process behind every particular design. To us, it's about finding a solution that solves the problem at hand, with added benefit to the local and global community, whilst embracing technological advancements to help us do more with less. Thank you very much.
Thank you so very much for sharing those videos and, of course, your opinions. And now to thank you, I'd like to request Mr. M.R. Ramaratnam from Saint-Gobain to please join us on stage. And I'd also like to request Mr. Rishi Kapoor to join us on stage once more. Thank you so very much, sir. We welcome you. And a Smart Green certificate for you. Thank you so very much, along with a memento. I request all three of you to please join us for a picture. Thank you so very much.